It's 45. So, yeah, you use I think there was some KPMG and Power BI.
I did the first one. And I just included every time. You're up to short or one.
Yeah.
You use every time.
Yeah.
Every time.
You're doing tax, but for assets.
You keep it around.
Yeah, so,
Okay, so let's get started. So again, the next exam is 2 weeks from today. So let's go through the homework assignment. And so the first part of the homework assignment, so part one of the homework was to, again, calculate this, I guess now we're doing value of an investment compounded annually, where we're prompting and where you're using functions. As I said, from now on, we're really going to be using functions to, unless I say otherwise, to Katie. So, and hopefully you got the mindset of this, so hopefully you did all four of them and you sort of graduated into seeing why doing this as using functions makes sense. So we're going to have a main, we're going to call main at the bottom, we're going to define a main function, and in the main function, you're going to prompt the user for three values: the balance, how much they're depositing, the interest rate, and the number of years. And then the problem said, call a function. Could have called it whatever you want. No, I said calc final balance, right? And you're going to pass it the three values that you read in: the balance, the interest, and the years. And so here's my call to the function. Here I'm passing the three values. And in this version of the problem, you are going to calculate what this value was, compounded annually, and then in the function, in addition to doing the calculation, you're going to print out what that value is. And so here we call calc final balance. Calc final balance gets invoked. Here I have the three variables that are going to be used in calc final balance. I decided to have variable names that were similar to what was in main. They could have been the same again, or they could be different. I simply prefixed the word balance and interest in years with IP for input parameter, somewhat of a convention. And then I calculated annually, I simply had a for loop which calculated for the number of years. So in year and range of years, this is going to give me, iterate through however many years there are. I'm going to now calculate what the balance is plus how much interest you get that year by simply taking the interest that was entered, dividing it by 100 to make it a percent, multiplying times the balance. That gives you what the interest that you're getting on that balance is, adding it back to the adding it to the balance, and then replacing the balance. So that's going to iterate around for however many years, and then you're going to print out that value out. The function's going to end. IP balance, IP interest, and IP years get destroyed. We don't really care at that point because we've done the calculation. Calculate final balance concludes. We come back to main. There's nothing after main, after the call to calc final balance, and then the program ends. Okay, is everybody good with that? And of course, okay, yes, if you didn't write this as functions, this program, well, sort of would have, you had to change the variables around, but effectively, the program, if you wrote it as one big routine, as we did before, would have been getting the variable, getting the values, and instead of having IP, would have been right? You have to indent, but that's effectively the sequence in which the code would have been executed. Doesn't tab back. Weird. Okay. So that's the first part. The second part I said is, okay, now change what you've done. So instead of printing out the result in the function, I want you to calculate what that value is and return it back to the calling routine and have the calling routine main printed out. So here's version 2, really almost exactly the same. The difference here is that now when I call calc final balance, I'm not simply calling it on a line by itself. Because calc final balance is going to return what that balance is, I'm going to call calc final balance, and I'm going to take that value and put it in another variable. And so now calc final balance is going to be almost exactly the same, but the difference now is instead of actually printing out IP balance in calc final balance, I'm going to return what that value was, IP balance, back to the calling routine. And now the calling routine now, whatever IP balance now is, that's going to be set, that calc balance is now going to be set equal to what IP balance is because the function returns that value. So I'm calling the function here, and since it returns a value, I am putting it in the variable calc balance, and then I'm printing out calc balance to 2 decimal places. I did not have to create a variable. I could have, in fact, I could have gotten rid of this and instead just inserted this here, and I could have just called the function, have the function return a value, and use that to print out. That would have been fine. And suppose, okay, everybody take a look at this. Right, so that's what I had originally. And suppose I said, you know what, then what I want you to do is assume you added, so you do this calculation, the interest rate and the number of years and whatever the original balance was. And then I said, take the balance, add $5,000 to it, and then recalculate what that balance is going to be at the same interest rate and the same number of years. Right, so I want to add to this problem do this original calculation as it is, and then after doing that, increase the balance from whatever it is with the interest by $5,000, and then recalculate what that balance is going to be for the same number of years at the same interest rate. And then print out what that's going to be. How would I alter this code to give that functionality? So what I want to do is Surya?
Make a new function that would pass the balance from calc final balance to the new function.
Why do we need a new function?
I don't think you do, but I think it'd be easy.
Okay, so you're saying create a new function,
Yeah.
and what is that function going to do?
It would take the new balance with the accrued interest past that value.
And then do the same calculation.
Yeah.
But I already have a routine that does that calculation, right?
So you pass it back.
So what could I do here? So I said, let's take this calc balance and add $5,000, right?
So you can just pass that back.
And I could actually I could copy this line. Actually, this would be get it? Everybody should get this. This is the whole point of functions. Because I have a function that does this calculation for me. The function takes a number, a balance, an interest rate, and a number of years. It doesn't care what variable it is, because here I call calc final balance with my original balance. Now I increase I did some calculation, got a new balance, and I want to do a new calculation. Note here, guys, look, this is the same call to calc final balance. And in fact uses the same last two variables, interest and years. In this case, I'm using this new value that has the addition of the $5,000 and the accrued interest. Here I had the original amount. But the function calc final balance could care less where the value this came from. Because again, the way this works is when calc final balance is run here, the value currently in balance, whatever the person typed in, is set equal to IP balance, as is IP interest and IP years. When I call calc final balance here, whatever value is in calc final balance, okay, note that these are two different variable names, but the function doesn't care. The function doesn't care because all it cares about is it says, give me a number, and I'm going to take that number, that first number, and in my function, I'm going to set it equal to the variable IP balance, and then I'm going to do my calculation. You got to get this idea. This is the power of the function. The power of the function is it doesn't care. It is not tied to one variable name. In fact, it's not tied to any variable name. It simply says, give me three values. I don't care where those three values came from. And I'm going to then do the calculation. And so while Surya, I'm happy that he said this, Surya's first instinct was, let's create a new function to do that. But then he reflected and said, well, I don't really need a new function to do that. This does it for me. And it's generalized to do it on any three values. It's not tied to a specific variable where it got called. You simply give it three values. It's like you're a calculator, and I give you two numbers. You calculate and give me the addition back, right? Do you care what the numbers are? No. Do you care where they came from? No. Same thing with a function. So the value of function, there's a couple of values of functions. One is that it's going to help you, and this is going to be what we're going to complete now with the other two parts of the assignment. It helps you break down a problem into smaller parts. It provides a mechanism for doing that. And that helps you solve the overall problem. The second value is that if you have a problem that has multiple parts, it allows you to use the same code over and over again without having to rewrite it.
Professor,
Yeah.
when I run it on my computer, it doesn't give me a different value.
Well, did you print it out? So you did this and you printed it out?
Yes.
You're saying it gives you the same answer that it gave you up here.
Oh, I didn't put the string function on. Okay, I got it. Never mind.
Agreed?
Yeah.
Remember what I said about the len function. Somebody wrote the len function. I can use the len function 87 times within my program. And I could pass it different strings to tell me, to ask what the length of that string is. I wrote my own function called calc final balance. I can call it as many times as I like, as many times as the problem requires, and all it asks me is, give me 3 values to work on. And I'll give you an answer. And I'll return that answer to you. And you can have a nice day after that with that answer. You can do with it whatever you want. And you can call me again as many times as you want within that program. I know it's a hard idea, but
Professor,
yeah.
so this line calc balance is equal to calc balance plus 5,000, would that be after the parentheses one? Like since we're defining it?
Okay, so, Nimra, so let's go through this. You're okay with balance getting a value, interest getting a value, and years getting a value. So it's 1,000, whatever, interest rate 10%, 5 years. I call calc final balance, passing it 1,000, 10%, 5 years. Calc final balance does its thing.
Yeah.
It returns to me 1,050. I made up a number. The variable calc balance now gets 1,050. Stop me if I'm saying something you don't agree with, you don't understand.
No, it's right.
We're good.
Yeah.
I take calc balance, which is 1,050, and I add 5,000. Now it's 6,050. Now I call calc final balance again, the function. What am I passing it? $6,050.
Oh, so you're doing that again then?
I'm calling calc final. Notice I'm calling it once first here and here again.
Oh, okay.
And I'm passing it here. I passed it 1,000. Now I'm passing it $6,050.
Okay, got it.
Got it?
Yeah, I thought that the question is that you're adding 5,000 in the beginning.
No.
Okay.
Obviously, if I said after this, add $10,000 in calc, again, all I would have to do is call calc final, add 10,000 to calc balance, and call it again. And I could call it as many times as I want. Okay. So let's go back to the homework assignment. I riffed a bit there. So the next part was modify the code so that you get the interest rate from the, modify the code from question 2 such that the main function calls a function to get the interest rate from the user. Hint, you should have a function that says get rate equal int rate. So let me see what I got here. So now I said, you know what, for the interest rate, what I want to do is I want to prompt the person for the interest rate, make sure that it's greater than 0. If it's not, give them an error message and get the right interest rate, and then return the interest rate. So now I'm changing my code here in main. Okay, so here I get the balance as I normally did before, and now I'm going to get, instead of simply saying float in interest, I'm going to call a function called getIntRate. Now this is going to be different for us. Hopefully you guys got it. It turns out that getIntRate doesn't have any parameter sent to it. It's actually sort of like the first function we wrote in learning about functions. And getIntRate, so now I'm defining getIntRate, and it has the first prompt to get the interest rate, and now it's doing some more to test to make sure that the interest rate's greater than 0, so I have I'm using while to do validation. This is sort of our normal while validation, use of while to do validation. At the end of this, op interest rate is going to be greater than 0, and so I'm simply going to return that. So whatever this get interest rate returns is going to be sent back here, and now the variable interest rate is going to get that value. So I'm using getIntRate to prompt the person for an interest rate and make sure that it's greater than 0. And then everything else is the same. And then finally, the last version is, I said, for the other two inputs, for the balance and for the years, I want to call a function that is going to get the balance, and there's some validation on the balance, and get the years, and there's going to be some, strike that. There's going to be years, there's going to be some validation on the years. And so now I said, why don't we create get functions? Just by convention, they start with the word get, but it sort of makes sense. It's a meaningful function name to say what it does. And so I'm going to have get balance and getIntRate and get years, and they're going to each work the same way, getting the value, prompting the user for a value, validating that it is an acceptable value, and then returning that value. And then I'm setting these same three variables, balance, interest rate, and years, to whatever those functions return, and then I'm simply going to call calc final balance. So all that I've done here is, as opposed to prompting the user in main, now I've offloaded, in terms of what main is doing, what that particular function to these other functions that prompt the user and also do validation, and then return a value that I know is valid. Okay. Anybody have questions on this? I handed out the solution if you didn't get it, so it's on the sheet that I handed out. All four of them. Where the get functions are effectively the same. They do different validations, but they're simply prompting for a value, using the while to validate that it's okay. If it's not, reprompt, get a correct value, and then return the validated amount, the validated number. Okay. So here's the way I want you guys to think about solving problems now. So let's take a look at main, and let's take a look at the thought process that I went through in solving this problem. This is a bit overstated because this isn't all that difficult a problem, and I clearly could have done all of this within main. But another way of attacking these problems is the following. The problem says, okay, get a balance, and here's the validation. Here's what you have to do to make sure that this is a valid balance. So I say, when I'm writing the program, okay, I'm not lying to you. I'm not lying to you. I do it this way. I say, okay, fine, this is going to be main routine, and I'm going to define main. Okay, so I sort of have my stuff set up. Obviously, it's sort of trivial what I'm doing here, but I'm using functions to solve the problem. The first part of the problem says, get the balance. And here are the rules for what the balance are. By the way, I'm simply going to repeat what I've just typed in, but I'm going to show you the way I think about it. You should watch this, because this is a good way of attacking problems. Okay, so he said, okay, get this balance, and he gave me this stupid validation stuff for what the balance is. So I say, okay, I know I got to get the balance. So I'll create a variable called balance, and I'm going to have to prompt the user. I'm going to have to go and do some validation, but I don't want to do that now. I want to sort of get a top-level solution to this problem. And I say, I'm going to call a function called getBalance. And I'm waiting till later on to write the getBalance function because I know in my heart of hearts that I'm going to be able to solve this, but I don't want to break my train of thought about how to solve this whole thing. So I said, fine, I'm going to write a function called getBalance, which is going to get the balance. Okay, what's the next thing? The next thing is, I don't remember if it's the right order, it doesn't make any difference. The next thing is that I got to get the years, and I've got to do some validation on the years. So I say, I don't want to write that, I don't want to do all that now, I just know I have to get it, so why don't I write a function called getYears that's going to get the number of years and return that value, and I know that it's validated. And then I've got to get an interest rate, and I've got to do some validation on the interest rate, but I don't want to think about the details of that, so I'm going to call a function called getInterest, and it's going to return a validated interest rate. And then the problem says, do this calculation to compound it annually and then print it out. I don't want to think about that right now, so I'm going to say that I'm going to create a variable calc balance, and I know that I'm going to write, I can't remember, I don't want to. And I know that calc final balance needs some numbers. It's going to need the balance because it needs numbers to work on. And now that I've calc final balance, okay, now I've got the result, and so now I'm going to print out calc final. I'm not typing all this stuff, but I swear to you, this is the way I think about solving problems. So now I've sort of broken up what this problem is into a number of subproblems that I know I'm pretty sure I can solve. But I say, okay, fine, I'm going to get these different parts, and now this is the solution to it. And now what do I do? Well, now I go and I define, I said, okay, this seems to make sense if I can write a get balance and get years and get interest and calc final balance. Okay, so now let's go and do that stuff. So now I say, let's write the function called calc balance. Get balance, I'm sorry. And now I write the function for get balance. And now I'm going to type this in, but so now I simply say, I start typing in this stuff. I'm fast forwarding here. And so now I write the code for get balance. And what am I going to do next? I'm going to do the one for get interest. And then get years, and I'm going to do get interest. Yeah.
Are you just trying to say like kind of like almost like writing in the paper, make an outline first in the bottom, and then go back to it?
100%.
Just execute it as you go.
That's correct. The reason why this is a better way of thinking upon it is that if you get caught up in the weeds as you do all this sort of nitty-gritty stuff here, you sort of lose sight of everything else.
Big picture.
So it makes much more sense to partition it. And sometimes your partitioning into these different functions doesn't work, but you go back. But what you really want to do is you want to solve simpler problems. If you have a big problem, if you have lots of problems with lots of different parts, you get confused. And so just concentrate on, as you say, make this outline, and then go back and then do the parts. And I'll tell you that sometimes when you do the parts, you break that up into subproblems. It's in engineering or computer speak, it's divide and conquer. Take a big problem and divide it into smaller problems and solve the smaller problem. And sometimes the smaller problem is too big, and so you break that up into smaller problems. Okay? And sometimes what I do, okay, is if I want to make sure that as I'm doing the solution, I'm getting the right answer, sometimes I will do the following. I'll say, okay, I got these things here. I'll say define get years. Here I'm going to use the same variables. And what I'll do is, suppose I write get balance and I'm not 100% sure it works, and I don't want to go on until I get it to work. So what I'll do is I'll write these other functions, and I'll say maybe here print balance. As sort of an intermediate step to make sure that my get balance function works. And once I know that it's getting me the right balance and it works properly, I'll take this out. And I might then write the get years and test to make sure that get years works. And I'm just writing these other functions so there's something there so the whole thing will compile and run, and I'm returning some stupid number. Then when I get years, I'm going to remove that and put in the actual code to return the right number of years. Okay, so, again, I get it. It seems the idea of function seems like it's adding additional complexity. You got to do some of it, and once you do, I think you're going to find that it makes actually solving a bigger problem easier because it forces you or gives you a mechanism for breaking it up into parts. Okay, so that's the homework. Do that. So, okay, let's do a couple of new things. So suppose what I want is a program that prompts the user for two integer values, start and end. And what I want to have a main function that passes these two values to the called function. And this new function will then create a list that contains the integers from the start to the end. And returns that list to main, and then main prints that list. And so the interaction would be that main is going to prompt for enter the starting value and enter the ending value, and then it's going to call this new function that is going to create a list of the numbers up to and including 4 through 8 and return that list, and then main is going to print that out. Okay, so let's see if you guys can try to write that function, write this code. So the code is you're going to write a main routine that prompts the user for starting and ending value. It calls a function that creates a list of numbers in the range and then returns the list. And then main is going to print out that list. And what you're going to see here, what you might say is, boy, he's returning a list. Is that going to make things any differently? And it turns out, as you're going to see, that lists behave the same way as regular numbers or strings, but it's better if you actually try to do it. So why don't you guys try to take 5 minutes now, and hopefully 5 or 6 minutes, and write the program that gives this behavior, enter starting value, enter ending value, and then create a list, and then print out the list. I'll keep trying to make things better. I'm failing. Yeah.
Do you want the last number in the list? Or?
Yes. Yeah, right, it's inclusive. So if you say 4 to 8, it's going to be Okay, so I started writing this. I had main. Again, this is sort of the way I attack problems. I have main. I define main. And I know I have to have start for a starting value and an ending value. There's no additional complexity for the starting or ending value, so in this particular case, I really decided not to create a function to get those values. There was no validation. So I just prompt the user for those. And now, what I want to do is I want to now call a function that is going to create a list that I want to print out. So I say, okay, let's write a function to do that. I'll call it create list. And create list is going to now create that list, and it needs to have the starting value and the end value, so I'm going to pass in those parameters start and end. I know that create list is going to create a list, and I'm going to dump that into a variable called main list. So main list will be a list, and then I can simply say, okay, I'm going to print out and that's the outline of my solution. So now that I've done that, now I can define create list. And I'll take a start and end value. And again, the variables can be whatever I want, so I'll reuse the same name. And so now I just have to now figure out a way of creating a list that has the starting value and the ending value. Hopefully everybody got that. So I'm going to create a variable called list, and we'll start it equal to nothing. And then I'm going to say, okay, why don't I generate the values in that range? So I'll create a variable val in range start to end plus 1. So I have to do the end plus 1 to get end in. And hopefully this is all downhill for everybody now. And so now what I want to do is I simply want to take list, and I want to append to list the value. So I'm just using the append method on list to append the value. And I'm going to return the list.
Spell list with the I.
Okay. Right? So the moral of this story is that not only can individual values be returned, so what we did for homework, we returned the rate and the years and the balance as some individual numbers, but you also can return lists where you have a list of values. And it's important to see that it's generalizable. You probably would have guessed that. You could obviously not only return numbers and lists, but you could also have returned strings. You could return any sort of value. The one reason why returning lists can be important is that I'll come back to this later. I just wanted to show you that you can actually have multiple values returned, and the multiple values can be the elements of a list. So that's actually nothing that's new. It's just an extension of what we've already seen. Now the next thing is new. And that's the following. I don't know that. So I mentioned to you that Python is an incredibly popular programming language now. And in it you can write your own code to do calculations, but it turned out, somewhat as a function of it being so popular, lots of people have written all sorts of libraries of programs, actually functions, that do things that are useful for you that you might want to incorporate in your program, and you don't have to write the function to do it. It's already built in. Okay, this is in the slide, so you don't have to type this in. So, for example, there are a bunch of math functions that exist within a math library of functions that we can use. For example, something that computes, well, forget about fabs, but something that does factorial. If you remember, factorial is take a number, it's that integer times all the other integers from there to 1. So if you ask for 4 factorial is 4 times 3 times 2 times 1. And so there is a function called factorial that will do that calculation for you. You don't have to write a routine that does that. Or there's a function that computes square root. There's no actually operator that does the calculation of square root, but somebody has built a library to actually do the calculation of factorial and square root, for example. But there are, I'm going to guess, hundreds of libraries of things that do it gives other functionality, and you do a Google search and look for that thing, and it would tell you what library it's in, and you would be able to use that. So what I'm introducing here is that there exist other functions that are not natively built into Python. So there are some functions that are natively built into Python, like len and int and float, where you don't have to do anything. But there are other libraries of programs where you can use those functions, but in order to use those functions, you have to do you have to type in one other command. So suppose what you wanted to do is you wanted to write some code where you took the square root of a number. How would you go about doing that? And you see here that there is this function built in called square root. So you want to make use of the square root function. But because the square root function is not one of the native functions into Python, what you have to do is you have to tell Python where that function is. And you do that by having at the top of your program the statement, the word import. You'll note that the word import is made orange because it's a reserved word for Python. And afterwards, you give the name of that particular library where that function is in. And when you read the documentation, it's going to tell you where it's in. In what I showed you, it's going to tell you that it's in this math library. And so the first thing you have to do is you're going to say import space math. And then by doing so, now you have access to all these different math functions, of which I have 3 of them here, factorial and square root. And if, in fact, you want to use these, you would say import math, and then I'm not going to write a function for this. So to use this particular function, the square root function, I would say import math. I would then, in order to invoke the square root function, I would say square root and pass it a parameter, but you have to prefix it with the word math, the library that it's in, and I just assign it to a variable, and then I can print it out. And so, in fact, it gives me 4. So, and if I wanted to use factorial, I would simply say math.factorial. Again, I've already said I'm importing the math library. All I need to do is to type in the name of the function I want to use prefixed by the library name. And it gives me the factorial of 5, which is 120. So we have at our disposal additional functions that are not natively built into Python. It requires us to find out what library they're in, assuming they exist in a library. And then we put in the name of the library using the import statement, and then reference those functions. It would be in the documentation of these. And you just have to prefix it with the name of the library. We don't have to do it with the native functions like length or string or import or float. Python just knows about those. We won't, I don't think, I'm not going to have a homework assignment on this, or where there's, I don't think I am, or the exam question using functions in the math library. I wanted to show you about libraries in general. There is one library I want to use. And that is a library that allows me to generate random numbers. So, is there any questions on this? There's not a lot. It's not that hard. It's just the availability of other functions. I suspect there's a library of finance functions and all sorts of things, statistical functions, and they all work the same way in terms of having the word import and then the name of that. They call a module here, and then simply finding out which of the functions within the module you want to invoke. You simply prefix the name of that function with the name of the module. Okay, so a function that we are going to use that is for this course is a value, is a function that generates random numbers. And everybody here should have experience with random numbers. We did this in 3727. We had Excel generate random numbers. And I'm hoping for people who have BQA 2812, you've seen the use of random numbers to do simulations, to model real-world phenomenon, like games of chance. So a random number is a number that's random. You can't predict what that number is going to be because lots of things in life are random, and we want to simulate those things that occur in life, this randomness that occurs in life. And so there's a library that has a random number generator. The name of that library is called Random. And the function to generate a random number is called randint. So randint is a function in the random module, I won't call it library, module, and it generates a random number between two values that you give it, inclusive. So you give it two parameters, m and n, where m needs to be less than n, and it'll generate a random number inclusively between m and n. So if you had randint, you had random.randint of 1, 100, it generates a random number between 1 and 100 inclusively. And the name of the module is random, and so if we wanted to generate a random number, so here I would have random and now I would have random.randint 1, 100, so that's going to generate a number between 1 and 100 inclusively and set that equal to x1. And if I wanted to generate a second random number, I could call it again. So this program generates two random numbers in the range of 1 to 100 and assigning it to x1 and x2, and then it just prints them out. So here you see that it generated the two random numbers 27 and 87. Right? So if I were to run this again, remember before it gave me 27 or something, let's just run it again. And it gave me two different random numbers, 82 and 20. So in theory, the probability in my range is a 1% probability of any number, and so each time it's going to generate, it could generate the same number again. By chance, that's possible. Unlikely. Okay, so why would you, any questions on this? Why would you use random numbers? As I said, there's lots of things in life that are random that we want to try to, but we want to try to take them into account and do simulation. So, for example, in games of chance, there's a die, okay, and a die has 6 sides, and in theory, unless the die is manipulated, that the probability of getting any number between 1 and 6 is 1 over 6. That's the odds of getting any number. And let's suppose we want to run some simulation based upon throwing a die or dice. Well, we could use this random number generator to generate a number between 1 and 6, right? We just call randint with 1 and 6, and it should generate a number between 1 and 6. And if I wanted to print out 20 random numbers, okay, so if I want to run 20 random numbers, I could write code. I'm going to say import random, and I'm just going to have this iteration go 20 times, and then this would print out each time a random number between 1 and 6. Any questions on this? Here I just used the for loop to have an iteration going through 20 times. I could have done 0 through 20 also. Range 0 through 20, it's the equivalent of 1 and 21. And all I'm doing is I'm printing out a random number between 1 and 6. Okay, so here's a fun exercise. Well, at least I think so. So why don't you run a simulation to see how good this random number generator is? See if, in fact, it generates, let's suppose, in 1,000 samples, if I were to throw the die 1,000 times, then in theory, the number of times it comes up with a 1 is going to be 1/6 of 1,000. The number of times it comes up with 2 is going to be 1/6 of 1,000. The number of times, right? So why don't you now take this code and now actually write code that is going to simulate throwing a die 1,000 times and then printing out the number of times it came up with a 1, the number of times it came up with a 2, the number of times it came up with a 3. See if, in fact, how random and how equally distributed those, the numbers between 1 and 6 are. Get it? So at the end of this, let's say 6,000 times. So what I want to do is I want you to throw the dice 6,000 times. Start typing. You've got to do 6,000 typing again. Just kidding. If anybody does that, I'm going to brain them. And then you're going to then print out the number of times a 1 came up, the number of times a 2 came up, and 3 and 4 and 5 and 6. And you don't have to use a function for this if you don't want to. It's fine if you do. Jeez. Okay, so one, a sort of brute force way of doing it, I guess, you should see if you guys do it. Let me show you one solution is I'm going to set up a count, 6 different counts to count the number of times it was a 1, 2, 3, 4, 5, 6. And then I'm going to set up a for loop to iterate through 6,000 times. So I'm going to go from 1 to 6,001, and I just have a variable I, which isn't going to do anything. And then I generate a numerator, I generate a random number between 1 and 6 and put it in the variable R, and sort of in a very straightforward way. Now I can test to see if R is equal to 1, then count 1 is equal to count 1 plus 1. How many people did it this way? Katie did? Okay. LFR is equal to 2, then, and then it's just a lot of cutting and pasting. Three, 4, 5, and then the last one here would be else count 6 equal count 6 plus 1. So okay, so, and then after I come out of the for loop, simply print out these values. So, sure, there's an error here. Oh, darn it. Problem is, so that's about 6,000. They're pretty. It's sort of interesting to see when to sort of see the percentage of how much it's off from. How everybody else get it to run? Okay. So what are some of the other ideas in terms of writing the code for this? Is everybody? I mean, this was pretty straightforward. Generate the random number, see if it's equal to 1, 2, 3, 4, and increment a variable, and then print out the variable. Chris?
Basically the same as you, except I had, instead of counts, I made a bunch of empty lists, and then I had each print statement and print out the length of the lists.
You dump the number in the list, and then you do the count of the list?
Yeah, so I said, like, if rand equals 1.
You love that idea.
Base 1 dot append.
Yeah, that's pretty good. So, yeah?
Instead of having 6 lists, I just have 1 list. I just adding each number.
Very good. Okay, so that's great. So this was another solution. Let's take a look at this. It's probably very close to, this is probably what Surya did and somebody else also, Chris did. So create a list that has 6 values and initialize it to 0. And then go 6,000 times, generate the random number, put it in an outcome. And then look what these guys did. They knew that the value of the outcome is going to be between 1 and 6, and so they used that as the index into the list. So they said outcome, whatever the outcome list is, which was initialized to 0. So take the outcome, that's going to be a number between 1 and 6. Subtract 1 from it because the indexes into the list are between 0 and 5, right? And so simply take that value, add 1 to it, and put it back. So they're using, that's very good. They're using the index, they're using the random number as an index into the list. And in that way, they didn't have to bother with all these different variables that I created. Chris had to create 6 lists, so this is even better. So this is, and then once they did that, then they simply had another for loop that went through each they went through each, so result was set equal to each element of the list. Remember, this is an outcome list, so result is going to be whatever it is, and they simply print out the value of the die and then the result. This is in the slide, so you can see that. So it's very clever to use the random number as the index. This worked out because the index was between 1 and 6, and they just had to translate it back to be between 0 and 5 because that's the way the list was set up. Okay, so, of course, it's a homework assignment for, I handed that out, right? Yeah. So, homework assignment for Monday, and we'll continue on doing functions, and have a good weekend.